In this video, we're going to prove the trigonometric relation that sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And then we'll explore that relation using the TI N-Spire CAS app. This image on the left will help us to keep track of our angles and line segments and triangles. We're going to start by identifying where the right angles are in this image. And remember that a right angle, of course, has a degree measure of 90 degrees and a radian measure of pi over 2. So we're going to mark those angles in blue, and we're going to see that we have a nice right angle here, and here, and here, and here. Down here we have our angle alpha, which is by definition, and we have our angle beta, which is by definition, and we're going to be looking ultimately for the sine of this angle here, which is alpha plus beta. Remembering that the interior angles of any triangle has to sum to pi radians, which is 180 degrees, we see that this angle up here has to be pi over 2 minus alpha radians, so that we get this angle, pi over 2 minus alpha radians, and this angle here, pi over 2 radians, and this angle here, alpha radians, sums to a total of pi radians. So this here has to be pi over 2 minus alpha radians. By exactly that same argument, this angle here, PQR, has to be pi over 2 minus alpha radians. The angle RQA is a right angle, and therefore the angle RQO has to have a measure of alpha, since OQA had a measure of pi over 2 minus alpha. And continuing to work in that area of the image, since the angle PQO is a right angle here, since this side is a right angle, then that means that the angle RQP has to be pi over 2 minus alpha radians, since OQR is alpha radians. So we're going to mark this one here as pi over 2 minus alpha radians. And that means that the upper angle in that triangle PRQ has to be alpha radians, which the image already marked. Now we'll note that we did not define the lengths of any of these line segments, and we have full freedom to define the length of any one of the segments, any length we want, then all of the other ones would follow. So we're going to take this line segment here, OP, this line right in here, and we're going to call that length 1. Now let's ask ourselves the question, what can we say about the sine of the angle beta? Well, in the triangle, which beta is the lower left angle, that triangle that is triangle OQP, in that triangle, beta, its opposite the opposite side to beta is the line segment PQ. And the hypotenuse is the line segment PO, but that's just equals 1. So sine beta equals the length of PQ divided by 1, or just the length of PQ. So we know that the length of PQ equals sine beta. Now we can ask the same question about what is the cosine of beta. Well, that's going to be the adjacent side in that same triangle divided by the hypotenuse, or the line segment OQ, make this black, OQ, divided by the hypotenuse of 1. That means that the length of OQ is going to be cosine beta. Now we can ask, what do we know about the sine of alpha? Well, that's going to be simply the opposite to alpha in that triangle OQA. So the side opposite to alpha in OQA is AQ. And the hypotenuse of that triangle is OQ. But we know the length of OQ. We know that the length of OQ is the cosine of beta. So the sine of alpha is the length of AQ over cosine beta, which means that sine alpha cosine beta equals the length of AQ. Now we're going to look at the cosine of alpha, and we're going to look in that triangle that's at the top, that triangle PRQ. And we note that cosine alpha is going to be the adjacent side in that triangle, which is the length of the line segment PR, divided by the hypotenuse in that angle, which is the length of this line segment PQ. But we already know the length of the line segment PQ from up here. That's sine beta. So it's going to be the line segment PR divided by sine beta. So that means for us that PR is going to equal cosine alpha sine beta. Now we're almost done. What is the length of the line segment BR? Well, we can see just from the formation of that rectangle that it's the same as the length of the line segment AQ. But we know from up here that the line segment AQ is sine alpha cosine beta. And now, finally, what is the length of the line segment PB? Well, PB is PR plus RB plus BR. And that is going to be, we know PR from right here, cosine alpha sine beta. And we know BR from right here, sine alpha cosine beta. But this line segment PB is the opposite side in this big triangle here, POB. And therefore, it is the opposite side to the angle alpha plus beta, which we have right here. And we know the hypotenuse of that is 1. So the sine of alpha plus beta is going to equal the length of PB. This is right here, which we know to equal, so we're going to change the direction of the sine alpha cosine beta plus cosine alpha sine beta all over 1, which leads us to our final conclusion, what we were trying to prove, that sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Now we're just going to test that relationship quickly in our TI N-Spire CAS calculator app. And we're going to create a new document and give it a calculator. And we're going to define 2 variables. We'll define the variable alpha and set that equal to pi over 8. And we'll define the variable beta and set that equal to pi over 7. Now we're going to ask the question, what is sine of alpha plus beta? And we're going to ask for this in approximate format or numerical format with a little curly equal sign. And we see it equals 0.745642. Now we're going to ask what is sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And again, we're going to ask for that in numerical format. And we see that we get the same answer. Thank you very much. I hope you've enjoyed this video and hope to see you soon.